Hey everybody, it's Brandon from STEM Tutor Club, and today we're going to try to understand fractional exponents. But first, let's show how to actually use this formula. So let's start off with a simple example just to make the numbers easy. Let's pretend that we want to calculate 3 raised to the power of 4 halves. Now obviously 4 halves is equal to 2, so this should equal 3 squared or 9, but let's just see if we can get that with and without the formula. So if we use the property, or if we do not use the property, sorry, then as I just said, we'll have 3 raised to the power of 4 divided by 2. 4 divided by 2 is equal to 2, and then 3 squared will equal 9. So we expect to get the answer 9 on this side. Now, there's actually two separate ways that we can do this. So we can look at it, with this first way or this second way. So if we look at it the first way, and I'll do the second way over here afterwards, but if we look at it this first way, then basically we can list which variable corresponds to what. So x is obviously 3 here. That's our base. And then n, the numerator of the number in our exponent, is equal to 4. And then n will be equal to 2. And if we work this out, what will we get? Well, on the left-hand side, we obviously have 3 raised to the power of 4 over 2 right here. And then on the right-hand side, we would represent this as the nth root, and in this case it's 2. So we'll say that is equal to the square root. So we could think of the square root, but you don't have to write out the 2 when you're talking about the square root. That's implied. For all the other roots you do, which we'll talk about later. But inside of the root, then we'll have 3 raised to the power of 4. So 3 raised to the power of 4. And you could also do this in a calculator, but another way to think about it is to actually expand this out a little bit. So if we had 3 to the 4th, that would be 3 times 3 times 3 times 3, which is really just 2 sets of 3 squared. So in other words, you could think of this as 3 squared times 3 squared, and then you could apply the square root to each of these individually. Again, this is, you don't need to know this. This is just another way to find the answer by hand. You could have also just plugged this in a calculator, but the square root of 3 squared will be 3, square root of 3 squared will be 3, and 3 times 3 will equal 9, as we expect. So we get 9 as we expected over here. That was one way to do it. What we could have also done is we could have also had the nth root, in this case the square root, inside. So if we do that, let me write that out. So again, we're going to have the same situation here. So the x, m, and n value are the same. So x is still 3, m is still 4, n is still 2. But now what we're doing a little bit differently is instead of writing it this first way, we're going to write it the second way. So 3 raised to the power of 4, 2, according to our formula, is now going to be the square root of 3, whatever that is, raised to the 4th power. Now the square root of 3 is obviously some decimal number. There's no way to simplify it beyond this, so we're going to have to rely on our calculator. Let me calculate this and see what we get. We expect to get exactly 9. So I just plugged it into the calculator, and here you can see the values. If we actually calculate the square root of 3, we get 1.73205, whatever, repeating. And this is going to be an irrational number, so it will repeat forever. If I try to approximate this value by taking the first, let's say, 6 decimal places, then you can see I get an answer very close to 9. I have to choose the exact answer here to get exactly 9, but you can see the point still stands. No matter how we do it, we still get 9, which means that the formula is valid, at least in this case. It's also valid. It's valid in every case, but we've just shown that it's valid in this case. I also just wanted to mention a project that I recently finished up. If you're struggling in your math class with how to actually study, so basically how to practice your math skills outside of class rather than in class, I just created a new book that might be handy for you. I'll be sure to post a link in this video and you can check that out if you're interested. So anyway, back to the video. In order to understand fractional exponents, we want to make the exponent as simple as possible. So what we're going to do is we're going to start off trying to understand what happens when the numerator of the exponent is 1. And that is actually the simplest case, and you'll see why that is in a second. But basically, we want to calculate this value. Now, if you plug this into your calculator, you will get a number out. But what we would like to do is understand exactly why this is happening. So the best way to do that I found, is to think of it like this. If we want to find out what this value is, what we can essentially do is set it equal to some value x that we don't know, and then we can treat this like an algebraic equation for us to solve. And the question is, how would we solve this algebraic equation? Well, what we're actually going to use is a property that we've already talked about before, if you recognize this property over here. Basically, what we're going to do is we're going to raise both sides of this equation, to a certain power to try and get this 1/2 power to cancel out. And if you recognize this formula, we're basically looking, you can think of 1/2 as our value for m, and what we're trying to do is find the n that would cause that to equal 1. Because if you have anything to the first power, it's just itself. So the question is, what would be that number? And the answer, it's always the answer, not just in this case, is the reciprocal. So the reciprocal, in this case, would be 2. So in other words, if we square both sides here, you can see how this would play out. If we have 4 raised to the 1/2 power, and then that entire quantity raised to the second power, based on this formula over here, we can rewrite that like this. 4 raised to the power 1/2 times 2. And then that's going to be x squared. And then if we work this out, what is 1/2 times 2? That's 1. So we get 4 to the first power is equal to x squared. 4 to the anything to the first power is just itself, so we end up with 4 equals x squared. So there we go. When you look at things this way, it might actually be clear what we're talking about. So in other words, we can tell here that x would have to equal 2. Because we're looking for the value x that, when squared, equals 4. Now, if you look through this, you can sort of see that taking something to the 1/2 power and squaring it are sort of the opposites of one another, and that's something that we're going to explore in a bit, but in general, this pattern is going to be true. We can do something very similar with, say, 27 raised to the 1/3 power. Again, I'm sort of choosing these numbers just to make the math easier on ourselves. You could choose any numbers if you have a calculator, but the numbers that I'm choosing are easy to calculate by hand. So we're going to start off the same way that we did last time. We're going to set this equal to some unknown x, which we're trying to find, and then we can basically treat this like an algebraic equation to solve. So if we raise both sides to a certain power, and again, we want to choose the power so that when we use this property on the right-hand side, we're going to multiply it by 1/3, and we basically want it to equal 1. So the number that we should multiply by in this case is 3. So we're going to raise both sides to the third power. And then if we sort of apply this formula, one that we proved in a previous video, on the left, and we simplify on the right, we'll end up with this. 27 to the raised to the power 1/3 times 3 is equal to x cubed. And then here, 1/3 times 3 is obviously 1, so we get 27 equals x cubed. And when you look at things this way, hopefully it makes more sense what the answer is. So what number, when we cube it, equals 27? And hopefully you recognize that the answer there is 3. So 3 times 3 is 9, and then 9 times 3 is 27. So that's the general idea. We're seeing a similar pattern here, by the way. So when we're talking about, just like we did before, when we were talking about something, raising something to the 1/2 power, that in some sense that was the opposite of squaring, we see the same thing down here. So when we take something to the 1/3 power, that is in some sense the opposite of cubing, or raising it to the third power. And this is an idea that we're going to go a little bit deeper on right now. So if we look at this table, we can start to make sense of certain kinds of fractional exponents where the numerator of the exponent is 1. So if we have something raised to the 1/2 power, based on what we saw before, that was the opposite of x squared. And what is the opposite of x squared? If you remember your algebra rules, it's the square root. So in other words, x to the 1/2 power is the square root of x. That's another way to think about it. They're really just different ways of representing the same thing, because they're both the opposite of x squared, so that means they both have to be the same thing fundamentally. And then same idea with all the other possible roots. So x to the 1/3 power, that is the cube root of x. That's just another way of representing it. And again, that's the opposite of x cubed. And it doesn't matter what the denominator of the exponent is, this pattern still holds. So x to the 1/4 power, 4th root, x to the 1 over 100th power, 100th root, x to the 1 over n power, nth root. So that's the general pattern that plays out. So this is actually a lot of progress, because this at least tells us how to handle the denominator. Now, if we look at this original problem that we were given, there are basically two separate ways that we can represent it. So if we do that using this formula, we can either represent it this way. So we can do, let's see, 3 raised to the power 4 over 2. We can represent that as 3 to the 4th power to the 1/2 power, or we can represent it as 3 to the 1/2 power raised to the 4th power. And when you look at things this way and you remember the definitions that we started with before, you can see why this would work. So raising something to the 1/2 power, like we said before, is equal to the square root based on what we proved. So that'll be 3 to the 4th. And then here we're looking at the square root of 3 raised to the 4th. And this is what the first formula that we started off this video with says. So they're basically two ways of looking at it. So, and by the way, it's sort of implied here that the square root is the second root. You don't have to explicitly write it, but that's implied. For all the other roots you do. But you can see that this is the exactly what the definition says here. So in other words, based on what we proved before with exponents raised to the power 1 divided by n, as long as we can come up with a way to think about that, which we did earlier, and as long as we believe this formula, that directly leads to the definition of fractional exponents. So I hope that made fractional exponents make a bit more sense. They're really just a combination of the algebra rules that we are already familiar with and exponent properties that we've already proved. When we combine them together, we get this new rule out, which is worth writing down as its own property. Now be sure to stick around as we go over how we can actually use this fractional exponent formula and why it's actually beneficial to us.